This short presentation is about PV panel short circuit protection. PV panel or array short circuit protection offers a unique challenge due to the unique current voltage characteristics. This presentation is about this challenge, as well as a possible solution. Conventional short circuit protection, using fuses, does provide a level of protection, but due to the unique current voltage characteristics of the PV panel, fuse protection is typically delayed and not instantaneous. The PV protection proposed in this presentation is aimed at filling the gap left by fuse protection. The proposal is for faster, more intelligent short circuit protection. A further complication with PV installations is the high DC voltages. 1000 volt DC is commonly used, and there is a drive toward 1500 volt. This in itself is quite a challenge for fuse protection. Let's explore typical PV panel specifications. This shows the electrical specifications for a well-known range of PV panels. The power ratings for the different models start with 395 watts and ends with 420 watts. Note the two highlighted sections in the table. The first highlighted line in the table shows the PV panel operating current. This is the current that the PV panel would normally supply. This current remains the same when a number of these panels are connected in series to form a PV string of panels. The second highlighted line in the table shows the PV panel short circuit current. This current also remains the same when a number of panels are connected in series to form a PV string of panels. The important aspect to point out here is the relatively small difference between the operating and short circuit current of PV panels. The two values differ by no more than 7%. Usually, the operating current and short circuit current in an electrical network differs by orders of magnitude. Take for example, a typical single-phase household supply, where the operating current is 15 amps, and the short circuit current can range from 2500 amps and higher. Discriminating between normal operating conditions and a short circuit is rather simple in this case of a household circuit. Not so with PV panels. The challenge with PV panels is to discriminate between the normal operating current and the short circuit current, when the difference between the two is no more than 7%. Note that these are typical values and that the operating current and the short circuit current varies with operating temperature and sunlight intensity, making it even more of a challenge to discriminate between the two current values. PV panels are usually operated at, or near, their maximum power point to ensure maximum energy production. The question arises, why is there such a small difference between the operating and short circuit current of PV panels? The reason is quite simple: the smaller this difference, the lower the PV panel losses. It is obviously a design objective to keep the PV panel losses as low as possible. Ideally, the PV panel designers would like to have this difference zero, but that is not possible. This relatively small difference between the operating and short circuit currents of PV panels makes it difficult to detect and protect against short circuits using fuses. Next we shall explore why this is so. Let's explore an example, using the PV panel example specifications we have used so far. Let's look at the current versus time for a typical fuse that is recommended as a fuse suitable for PV panel short circuit protection. This is what a typical fuse curve looks like. Note the three different regions, colored red, gray and green. These are identified as the will not trip and will trip instantaneously regions. The tripping zone is indicated as the curved area between the red and green areas. The maximum clearing time is given by the right edge of this center area. The minimum clearing time is given by the left edge of this center area. This vertical green line shows an example of continuous operating current for this fuse. If the current falls to the right of this vertical green line, the fuse will trip at some point, but not instantaneously. If the current falls to the left of this vertical green line, the fuse will never trip. The operating current for this fuse therefore lies to the left of this vertical green line. So, where does that leave us with protecting PV panels against short circuits? Let's use the 420 watts panel in the range, and work through an example of selecting a fuse for short circuit protection. This graph shows the current time curves for a range of PV panel protection fuses. The fuse ratings are shown in the rectangle on the graph, starting at 3 amps, 3.5 amps, and ending with 12 amps. The fuses are rated at a maximum operating voltage of 600 volts. Let's take the operating current for the 420 watt PV panel, and indicate that as the blue vertical line on the fuse curve. We do the same for the trip current for the 420 watt PV panel. The trip current is drawn as the vertical red line to the right of the blue line representing the operating current. The question is now, which one of the fuses should we use? The first observation is that the fuse curve must be to the right of the blue line, to ensure that the fuse never blows under normal operating conditions. This means that the 8 amp, 9 amp, 10 amp and 12 amp fuses can be used. The second observation is that the curve must cross the red line from right to left, to ensure that the fuse does blow under short circuit conditions. Of the identified curves in the first observation, it is only the 8 amp fuse that complies with this condition. Reading from the vertical axis from the graph, the 8 amp fuse will trip after 100 seconds, when the PV panel current rises to the short circuit value of about 9 amps. This is quite a long time for a direct short circuit, before the fuse clears the fault. Also, this time can vary with operating conditions. This slide summarizes the previous example. The fuse for the 420 watt PV panel is the 8 amp fuse, and it will only trip after 100 seconds of a direct short circuit. The question is therefore, is there a way to improve this and activate a short circuit trip faster? We ask the question, is there a way to improve this and activate a short circuit trip faster? The answer is, yes, there is indeed a way to improve the short circuit protection of PV panels. The answer is to use an intelligent PV protection relay. This PV panel protection relay is connected to the output of the PV string. The PV panel protection is connected between the PV string and the fuse. The PV protection relay offers fast short circuit protection, in the range of milliseconds instead of seconds. The PV protection relay supports the fuse protection, and it is not meant to replace it. This protection is independent of the inverter, and it is implemented for each of the PV strings in the array. This means that the protection is at string level, and the whole array is not affected by a fault on a single string.